In the previous video, we focused on adding an instance on a face and rotating it perpendicular to the face normals. In this video, we'll work on the instance placement on top of the face. As you can see, the cube is only half visible. It's the same with the cone instance. The goal is to have any geometric instance appear snapped to the face, rather than being submerged half in the face of the source geometry. Let's get started from where we ended the last video. You can see the torus is only half visible. Let's look at the left view. Press Shift+Z for wireframe mode. You can see only half the torus is visible. We need the torus to be on top of the face. As a quick demonstration, I'll add a transform geometry node after the object info node. Set Z under translation to 0.2. The torus now sits on top of the face. Let's test if it works the same on different face selections of the source geometry. Now let's try with a different type of geometry. I'll switch to cone. You can see that the cone is only half visible. Let's adjust the translate property of Z-axis in the transform geometry node. We'll have to set it to 1 meter to make it work. Switch back to torus and it's way off the selected face. We need a better dynamic solution that adapts to the geometry of the instance. Press Command or Ctrl+X key to remove the transform geometry node. This will remove the selected node but retain the connection. Now let's add a bounding box node. The bounding box node creates a box mesh that encapsulates the input object. Let's add a viewer node by holding Shift plus Control key and left-clicking the bounding box output. You can see the bounding box. Let's unhide the torus object in the outliner. You can see the encapsulation. Let's unhide the cone object and select it in Object Info node. Now the bounding box encapsulates the cone and the dimensions have changed. Switch back to torus in Object Info node. Connect min and max outputs to the viewer node. Uncheck the As instance on Object Info node and uncheck Pick Instance in Instance on Points node. We need this to access geometry data. You can also add Realize Instance node between bounding box and Object Info to get the geometry data. You can see the geometry data is now displayed around the bounding box. Select Realize Instance and press X to delete it. I'll just uncheck the As Instance option. The bounding box provides position values on how far the box extends in both positive and negative axis direction. Max output provides position values in positive axis direction. Min output provides position values in negative axis direction. Let's use these values to proceed. Select and press X to remove the viewer node. Hide the torus in the outliner window. Press Shift+Z to enter material preview mode. Let's add a vector math node to bounding box. Connect min and max output to the vector math node. Hold Shift plus Control and left-click Vector Math Output to add a viewer node. Connect min and max output to viewer node and also the vector math output. You can see the vector output is 0 for X, Y, and Z axes. Let's change vector math to subtract for a non-zero value. We need positive values. Let's subtract max with min. Connect min output to the last vector input and max to the first vector input. Now we have positive vector output. We are only interested in the positive z-axis value. Select Viewer node and press X key to remove it. Let's add separate XYZ node to separate the vector output. Add a viewer node and connect X, Y, and Z output to it. Add a math divide node to the Z output. Let me explain why we are doing this. Let's enable torus from the outliner window. The height of the torus, represented in Z value, is 0.5. The half of that is 0.25. We get that by dividing the Z value 0.5 with 2. Set the divide node's second value to 2. We get the desired output. Shift plus Control and left-click on Divide Output to view the result. Select Viewer node and press X to remove. We'll use the output of Divide node to offset the node position. Now let's add a Combine XYZ node to the Divide output. Connect the Divide Math node output to the Z input in Combine XYZ. We only need to offset the object along its Z-axis. Hence, the X and Y axes are set to 0. Now let's add a Set Position node. Set the Combine XYZ output to offset input of Set Position node. Connect Object Info's Geometry output to Set Position Geometry input. Connect Set Position's Geometry output to Instance Property of Instance on Points node. Remove the Viewer node if you've added it. Now we can see that the torus instance is placed on top of the selected face. Let's check with the cone instance. The cone is placed on top of the selected face as well. Let's see how the monkey mesh is aligned. Press Shift plus A and select Monkey in 3D viewport. Hide the monkey, Suzanne, in the outliner. Select Suzanne in Object Info node. Press Shift plus Z for Material Preview. Suzanne is aligned as intended. Select a different face on the source object. Check with different objects. Let's also check how a cube would be placed. Press Shift plus A and select Cube in 3D viewport. Hide the new cube in Outliner and select it in Object Info node. Disconnecting the offset input shows how the cube is half submerged. Reconnect the offset property. It works as expected with different geometry types. This is the final node setup to add an instance on a selected face of the source geometry. Let's clean up and rearrange the nodes. Thank you for watching. Like and subscribe for more.